Hello guys, my name is Andres Sava and today I will be discussing the baking soda and vinegar rocket experiment using vinegar and baking soda. The materials that we will be using today is baking soda and vinegar. Weak acids. Weak acids are acids that don't completely dissociate in solution. In other words, a weak acid in any acid that is not a strong acid. The strength of a weak acid depends on how much it dissociates. The more it dissociates, the stronger the acid. A weak acid is an acid that doesn't produce many hydrogen ions. When in aqueous solution, weak acids have relatively low pH values and are used to neutralize strong bases. Some examples of weak acids are acetic acid, which is vinegar, lactic acid, citric acid, and phosphoric acid. A weak base. Weak base are basic it's a basic substance that do not completely ionize in water. An example of a weak base is ammonia. When ammonia is dissolved in water, a part of it dissociates into ammonium cation and hydroxide anions by interacting with the water molecules. A weak base is a base that, upon dissolution in water, does not dissociate completely, so that the resulting aqueous solution contains only a small proportion of hydroxide ions and the concerned basic radical and a large proportion of undissociated molecules of the base. Some examples of weak bases are sodium bicarbonate as baking soda, magnesium hydroxide as antacids, aluminum hydroxide as deodorant. Some weak base characteristic is the substance carrying a weak base has a pH of more than 7. A weak base is capable of making changes to its indicator's color. Weak base sometimes causes irritation and skin burning. It is bitter and shiny on the skin. Although weak, they conduct electric current. A weak base can neutralize weak acidic solutions. The reaction of vinegar and baking soda is we have the acetic acid, which is the vinegar, with reacting with the sodium bicarbonate, which is the baking soda, producing sodium acetate, water, and gas, carbox, and gas, carbo, CO2. Before actually performing the experiment, I would like to show you how quickly react the weak acid with the weak base when they come in direct contact. This is another experiment that I performed. Vinegar in the bottle, baking soda. You see how quickly they react when they come in direct contact. All right. This is the experiment with the baking soda and the vinegar in a closed bottle. So I put the baking soda inside a paper towel in order to avoid having direct contact with the vinegar inside the bottle, and that is because I needed some time to get away from the bottle before the action. Here I shake the bottle a little bit so the reaction occurs a little faster. So the experiment was partially successful. I waited a few minutes and nothing happened, but I could see from far that the bottle got expanded and got bigger, indicating that carbon dioxide was produced from the two compounds in gas form. So I think I didn't wait enough long enough, so I went back to check on the bottle. I touched it with a broom. Nothing happened, so I went to open the bottle and perform the experiment again, and then this happened. So you can see the explosion when I was trying to open the bottle. Um, the reason this is happening is because acid and base, such as acetic acid in this experiment, which is vinegar, reacts with the sodium bicarbonate, which is the base or the baking soda, and produces carbon dioxide. The base, sodium bicarbonate, undergoes a decomposing reaction, which is exposed to the acid. This produces a gas called carbon dioxide, which causes the bottle to expand because there's no way out from the for the gas to escape. The carbon dioxide escapes the solution as bubbles. The bubbles are heavier than air, so the CO2 or carbon dioxide collects at the surface of the container. And since the bottle is closed, there is nowhere to go. Gas expands when placed in a closed container. The molecules continue to move about, filling the container. They strike the sides of the container, and each hit creates pressure. They are attempting to escape the container. When they cannot escape, they strike the inside wall and then bounce around. As I said, the bottle was tightly closed. The more molecules striking the inside wall of the container, the greater the pressure. This concept represents the kinetic theory of pressure, resulting in the explosion of the bottle.